For week two's interactive advanced concept assignment, we did a chemical clock experiment. So solution one received 1,000 milligrams of vitamin C. I had 500 milligram tablets, so I used 4 tablets, which were dissolved in 60 milliliters of distilled water and 12.5 milliliters of povidone iodine solution, which was 10%. The video used 25% milliliters of iodine tincture, so I thought that since mine was double, I would use half the amount. After visiting multiple stores in my hometown, I actually discovered that they didn't carry iodine tincture, so I figured that I would go ahead and would try the experiment with the povidone iodine solution, and if it did not work, I would order some off the internet. In addition to the vitamin C and povidone iodine solution, I added 340 milliliters of distilled water. Solution B had approximately 0.4 grams of cornstarch that was dissolved in 60 milliliters of 3% hydrogen peroxide, which was then added to 350 milliliters of distilled water. So the first time that I mixed the 60 milliliter solution of A with the 60 milliliter solution of B that was warmed to 100 degrees Celsius, there was no color change. So the second time that I mixed the two, I decided to warm solution A as well as warming solution B. So solution A, which was 100 milliliters of the solution, was warmed to 104 degrees Celsius, and the 100 milliliters of solution B was warmed to 101 degrees Celsius. After warming both of the solutions, the blue-black complex appeared within approximately 1 minute. So this reaction used in this experiment is a classic example of a chemical clock. The term chemical clock refers to a reaction where the concentration of one of the chemical components undergoes an abrupt change in concentration after a time period and leads to a sudden change in color. The reaction in this experiment is termed an iodine clock reaction because it is the molecular iodine, or I2, that undergoes a sudden concentration change. When the iodine concentration increases, it reacts with the starch in the solution to form a complex, turning it a deep blue-black color. This reaction is shown in equation 1. So the I2, which is the aqueous solution, plus the starch, which is also an aqueous solution, is then turned to an I2 starch complex aqueous solution, which is that deep blue-black color. The experiment focuses on the reaction of iodate ion, which is IO3, with an acidified solution of sodium bisulfite, or NaHSO3, containing the starch indicator. The reaction occurs in 2 steps. The first step generates iodide ion, which is the I in equation 2, which occurs slowly and is the rate-determining step. A rate-determining reaction is the slowest step in the reaction mechanism and is assumed to be equal to the overall reaction rate because the reaction cannot go faster than the slowest step. So, as the iodide, which is a colorless ion, is produced, it is quickly oxidized to iodine, which is the colored I2, by the iodate ion, which is shown in equation 3. However, the iodine is reduced immediately back to iodide sulfate by bisulfate HSO3, as seen in equation 4. Since this step occurs extremely fast, the molecular iodine does not exist long enough to react with the starch, and no color change is observed until all of the bisulfate has reacted. At this point, the iodine in equation 4 is no longer being converted to iodide, as there is no more bisulfate available. The iodine reacts with the starch in equation 1, and the blue-black iodine starch complex appears. This means that the appearance of the blue-black color is a signal that all of the bisulfate ions have reacted. This type of reaction is often called a chemical clock because of the time it takes the chemicals to react happens very predictably, like a regular clock. So first on this page is the equations that I was explaining throughout the experiment. This first picture is a picture of both solution A and solution B. So solution A is the 1,000 milligrams of vitamin C dissolved in 60 milliliters of distilled water with 12.5 milliliters of the povidone iodine solution. And then it had 340 milliliters of distilled water added to that. Solution B is the 0.4 grams of cornstarch that was dissolved in the 60 milliliters of 3% hydrogen peroxide, and then 350 milliliters of distilled water added to that. So This next photo is a picture of the first time that I tried to mix the two solutions. It was approximately 60 milliliters of solution A and 60 milliliters of solution B. Solution B was warmed to 101 degrees Celsius. However, this did not produce a color change. This third photo is a photo of the second time mixing solution A and solution B. However, unlike the first time, I had warmed solution A to approximately 104 degrees Celsius and then added that to solution B that was warmed to 101 degrees Celsius. And this last photo is a comparison. So the first trial was in the mug, whereas the second trial, where both solutions were warmed, is the reaction of solution A and solution B, which were warmed. Thank you.